Hello everyone, I hope you are all doing well and welcome to another video series of Mastercam the complete course. So we have already started the module number 2, which is all about the 2D design and toolpath, and we have covered the topics like the 2D sketches and geometries and toolpath and chaining manager, milling depth cuts, milling lead in and lead out, milling multi-passes. And we have all discussed the milling additional parameters, cutting speed, feed, all these parameters. Some toolpath we have discussed like the contour toolpath, tool and tool folder. So today we are going to discuss the most important topic in the 2D design and toolpath, which is all about the toolpath type. And we are going towards to study the facing toolpaths, pocket, slot, contour, drilling and model chamfer toolpaths. So this is a very important topic of the module number 2, and we're going through all these steps one by one. We're going to create some geometry and some add some tools and apply some 2D toolpath strategies on our geometry. The first thing we're going towards the facing, then pocket, slot, contour, drilling, and model chamfer toolpaths. So let's get started. So here I have already opened the Mastercam 2022 version. I have the Mastercam 2022 and also 2023. Let me open the Mastercam 2023 version. So I mostly work on 2022 version, but for education version, let me open the Mastercam 2023. So just double click on it and wait for the software to load to your computer. So this is a very important topic. You have to focus, and we're going towards all these steps which we have already discussed in our previous lectures, just like creating some geometry and some profiling to the geometries, and then we're going to apply some to these toolpaths. So here the Mastercam 2023 version is open, and let's go towards the wireframe and create some geometry related to the machining operation. So first thing first, start with the simple rectangular geometry, using the wireframe tab and select the rectangle, make some simple geometry. Let's get anchored to the center and make a geometry. Make it 200 millimeter in the width and the height is 100 millimeter. Okay, and for some pocket operations, like we have to discuss the pocket, slot, contour, drilling, and model chamfer toolpath. So we have to create some pockets here. So we can create a rectangular pocket, not right in the anchor. Let me make the rectangular pocket over here and make it 50 millimeter and the height is 30 millimeter. Okay, and we're going to make circles here, and the diameter is 5.0, and make it more holes over here, here, here. So you need to create simple geometry, not a difficult one. So I just create a geometry, and let me define the circle over 5.0 millimeter, and I just double click on it, and what I'm going to do is I'm gonna define the radius or diameter. You can just make it 2.5 millimeter, or just make it like this 2.5, or it's very simple. You can just drag and drop and create radius according to your requirements. Blah, blah, blah. So I'm going to delete this, and I want to make the geometry in a linear way. So I'm going to use a different tool, which is in the transform tool. Let's go to transform, and I want to make these holes in a linear way and equal distribution. So let me make the rectangular array command, and what I'm going to do is single direction, and the distance is 10 millimeter. And how about the instance, and make this 20 millimeter distance apart, and make it the opposite direction, give like that. Okay, so just make it 4 and give it like this. Okay, so I think these are enough, or make it some less, because it will create program, make program heavy. So okay, we have the holes, we have the rectangular pockets. So let me move this pocket inside this block. Okay, so go to transform tool and translate this object, and let me show you how we can translate. Select the method of method move. I want to move this, and I want to move it from this point to this point. Okay, so it's very simple. It's very simple. So I got the pocket here, I have the holes, and what I need, I want a slot. So I need to create some slot over here, and one simple slot. So let me create slot here. Okay, so I just want to delete this line, make the width 90 and height is 15.0 Okay, so just want to open this slot from here. So therefore what I have need is to delete or trim that entity. Okay, and this is how we can do this, but I want to join this entity with this. Okay, click escape to or enter to this. Going to select this and click on the delete button to delete this entity. So we got it, and just some round corners over here. So what we can do is, no, we don't need any round corners, because we have to perform the model chamfer command over here. So therefore we don't need anything. So we have a pocket over here. We make some 2D wireframe geometry, and we have selected the top plane. So we have the top plane selected by default. We create some holes which are a diameter of 5 millimeter and a distance apart of 20 millimeter in the Y direction and 10 millimeter in the X direction. Give some dimensions by clicking on the drafting and select the smart dimension. Click this entity 100 and this entity 200, and you can define this two part, those 2 points 15 millimeter, and this entity is 30, make 50, and holes which are 5 millimeter in diameter. So the sketch is defined, and So we need to define the this distance, smart dimension, and give it a. So also we can define that this part is a part of or at a part of 10 millimeter, and this part which far away in the y direction is 20 millimeter part. So the sketch is fully defined. So let's get started and make this 2D geometry and apply some 2D toolpath strategies and discuss it one by one. Okay, so let's get select the machine. We want to perform this using the milling. So I'm going to select the mill and select default. So we have the milling. Now we got the toolpaths where operation we're going to perform on this. We have the 2D toolpath strategies here. So we're going to apply 2D toolpath strategies. We have the 3D toolpath strategies, which is definitely applicable to the 3D part, not on the 2D part. Okay. And we have the multi-axis toolpaths for the multi-axis like 4-axis and 5-axis geometry creation and machining works. Okay. So right now we have to apply the 2D strategies on this geometry. So the first thing we need is to apply a face milling operation on this geometry. So facing is an operation in which a part face is cleaned using a face mill cutter. So we are going to clean the upper rough area using the face mill cutter, and the operation is called facing. The purpose is to make a level one side and make a reference to create further operations like a pocket operation, slot, and drilling operation. So we need to face off all that material using a facing operation. So for that purpose, I'm going to select the face mill cutter or face mill operation, click on this and select the geometry. Okay. So what I'm going to do is I'm going to select a chain. So this is what we have, the chain. I'll select the chain and we select the operation. Okay. So chain geometry is selected. Select the face mill tool. For the face mill tool, you have a library. So you can select the face mill cutter, go to select library, and we have a lot of tools here. So right now it is difficult to select the required tool. So therefore what I'm going to do is I'm going to use a filter tool over here. Click on the filter and select none. It will disable all the tools. I'll select one tool, which is face mill tool. It will look like this. Click and OK. So once you select the tool and apply a filter, you will get only the face mill cutter right here. So we have the face mill tool, which is 42 millimeter in diameter, and the length is 8 millimeter, and we have the 4 flutes. Okay. So I'm going to select this tool. You can give size by clicking on it, double click on it, and you can add some different parameters like the cutting diameter. Let me make this diameter to 30 millimeter, and the secondary dia is cutting diameter is 30, and the secondary dia is 50 millimeter. Over length is 40 and the cutting length is 8 millimeter. So it shows an error that tip angle tool diameter don't intersect. So what we are going to do is you need to select the appropriate dimensions or write appropriate dimensions while putting data into this space. Okay. So I make it default. I'm not going to change anything. Click finish. And here we have the spindle speed. So for the facing operation, if you have a mild strain and we're going to perform on a mild strain, means for that purpose you need to set the spindle speed between 1500 RPM to 1800 RPM. And it also depends upon the type of cutter you are using and type of tips which you have applied and which you have inserted into your cutter. Okay. And the cutting feed also. Also, it depends upon the depth of cut and the removal rate and how much material you need to remove from the surface. So for that purpose, I'm going to remove a little bit material from the surface. So I'm going to make it 1800 RPM and the feed rate is 650 and the plunge rate is 300. Going to give a tool number 1 because it's an operation number 1 in any milling operation. So therefore, I give tool number 1 to this operation, which is a facing operation. And the tool holder is by default. I have selected the by default tool folder and the cutting tool parameters. So we have the cutting tool parameters. Here you have to select the appropriate cutting parameters while performing the toolpath strategy. So if we talk about the cutting method, it is a single way or one way cutting method. And if you're going to select a zigzag, it will work like this. Okay. So this is the zigzag method. So what is the purpose of one way and zigzag way? The zigzag way cuts the material in a two-way direction, and it will reduce the cutting time, the surface finish, and all this purpose. Okay. So one-way pass is a single pass way, okay, or if we talk about the dynamic, it will dynamically face of the material. So the best option is to select a zigzag way, and the next thing is the tip compensation. It is by default the tip and make the corners sharp. The next thing is stock to leave on the floor. We want our stock to be according to our dimensions which we have given. So what we want is we don't need leave material on the stock. We want 0 size on the stock after the facing operation. So the next thing is the overcross, which is 15 millimeter of the cutting tool. It means that the cutting tool will be cross over according to its diameter, which is 42 millimeter. It's the diameter of the cutter, but it will take 21 millimeter of that. So 21 millimeter is outside and 21 millimeters is. The along over tab is 110%. The upward distance is 50. And the exit distance is 50. So the method is a climb milling method, and the step over distance is 75. It means that the percentage of cutter being used is 75%. Mean to say the diameter of the cutter is, total diameter of the cutter is 42 millimeter, in which only 31.5 millimeter will be utilized while cutting operation. Okay. So let's give the depth of cut. Let me define that we want to remove the material in two cuts, and we want to remove 1 millimeter from the surface. And for that purpose, what I'm going to do is I'm going to remove material in a 2-step. So for that, I'm going to write 0.5 millimeter. So definitely it depends upon the type of cutting tool you are applying and or what is the material of the workpiece and the type of machine you are using. all these factors depend upon the depth of cut. Okay, so keep tool down. It will always down the tool while cutting the operation is performed. And let's go towards the linking parameter, and we have the links parameter. Every tool path is linked with each other. How it will be come through these, get inside the workpiece and take a cut from where he has to take a cut, and then what is the depth of the material you want to remove. Okay, so all these things are related with the linking parameters of the tool. Okay, so let's define that our top stock is 00 once the tool has to be referenced at here at this point. So this point is called the 00 point, and after that, how much amount of material you want to remove. So you need to set the depth here. So as I discussed, I want to remove 1 millimeter material from the surface. It means that from 00 to -1, it will take 2 steps to remove 1 millimeter material from the surface. So how about the feed plane? And I'm going to set 2.0 feed plane, and the check point is per defined. The home axis is by default. We don't need to change anything because it's a default position. And how about the arcs? Don't change top plane. Yes, we have the top plane. You want to select the coolant, then select coolant on, and it will do cool down the tool and the material. So why we use coolant? Because if you are going to perform machining on a hard material, if you are using the stainless steel or forged material or any hard type material which has a high carbon rate inside, so for that purpose you need to add coolant in your operation to cool down the cutting tool and the workpiece. It will create a better surface and remove the chips away from the workpiece. Okay, so we have also set all the things which we need to perform the facing operation. Just click OK to generate a tool. So here you see that the cutting tool we're using is the face milling tool, and it will take 2 steps to perform facing operation. What I can say that 1 millimeter I have to remove the material from the surface, and what it is going to do is it will take 0.5 millimeter and remove the material from the surface. So let me show you how it could look like. So this here option is called the back plot selected operation. So we have already selected the operation, and after click on this icon, which is a back plot selected operation, it will show you how it looks like. So you can slow down it to show this operation in a slow motion. So this is how it will work. So I'm going to give a top view actually how it looks like. So go to view, let me hide the grid also. So you see that 75% of the tool is being used in this operation, and along with 50% of the tool is outside. Sorry, 110% of the tool is outside. So the approaching distance is according to the parameters which we have set. So let me make it fast. So what he did is it takes the cut from here, never goes back to this point, but it takes a cut from this point. And after cut this step, it will go off and in the up direction. So this is what we call the facing operation. It will remove the material from the upside. Okay. So the next operation which we are going to perform is the pocket meaning operation, and we are going to create pocket over here. So for that purpose, we are going to select pocket operation, go to toolpath and select pocket. So here we have the pocket operation. Click pocket. So where we need to create a pocket, we have create a geometry over here. So this is the geometry. Let me select. So I selected the geometry. I want to create a pocket here. Click OK. And we got a pocket selected and we have the change geometry selected. Now select an appropriate tool for the geometry. So we have the 13 millimeter height and 50 millimeter in length of the pocket. And for that purpose, I need to select a tool which is an end mill tool, and it has a flat end at the end. So I'm going to select the 8 millimeter end mill, and I'm going to give it tool number 2. Okay. And the spindle speed is 6000 RPM. Feed rate is 1500 millimeters. And how about the plunge rate is 300 millimeters. So plunge rate is defined the speed or the rate how the cutter will plunge into the workpiece or take a depth. Okay. So let me define the default tool holder, and how about the cutting parameter. So our pocket is a standard pocket. It is closed pocket. It has no open end. So therefore, what we're going to do is I'm going to select the standard. It's by default. And what we need is we want exact size of the pockets. For that purpose, you need to set 0 on the leaf on the walls stop. Okay. Stop to leaves on the floor is 0.0 millimeter. So it will create 50 millimeter in the length and 30 millimeter in the width pocket. If we give some additional measurements, like if I go and write 0.5 millimeter, it will leave the stop from the walls of the pocket. So definitely this size goes to 49 because 0.5 millimeter from this side, 0.5 millimeter from this side. Total we have the 49 millimeter, and then 0.5 millimeter from this side and this side. It will remain, or it will not remove the material from this side, and make this the width is 29 millimeter. But if you want to create an exact amount, then you have to set it 0.0. Okay. How about the roughing operation? Because we have two operations in the 2D. One is the roughing operation and the other is the finishing operation. So as our geometry is a square geometry, and for that you don't need to have a spiral type shape to cut this pocket. You can actually create this pocket by using a zigzag method. So one thing you should have to notice that if we are going to select a zigzag, it will create round corners around this geometry. So it looks like a sharp corner, but in actual the cutter is a round, and we are using the 8 millimeter cutter. So it will create 4 millimeter radius on each corner. It will never create a exact square or a right angle pocket. Okay. So you have to be ensured that you have to select an appropriate cutter to minimize the corner radius. Okay. So on the milling operation, you have definitely, if you have a geometry, a square geometry, or you have a right angle geometry, you will never get the exact 90-degree geometry, but your corners will be round because of the cutting tool you are using. So the percentage over is 15 millimeter, mean to say that we're using the 8 millimeter tool, and the 50% means 4 millimeter will be utilized. Okay. So how about the entry method is the helix? Let me define that the helix method is not appropriate with this geometry. So I'm going to select the off. And the finishing operation, just give one step to finish the pocket. Okay, how about the lead in and lead out? So this is how the cutter will be get into the pocket and how it will be removed. So for that purpose, we have selected that the cutter will be in a downward direction. So we don't need to make lead in and lead out, just it will plunge into the surface of the workpiece and create pocket accordingly. So we just select the keep tool down position and don't need to enter in a helical way or in an arc way. Okay. So for depth of cut, so we need to define the depth of cut. So actually, we are performing the pocket milling operation, and for that purpose, we have to define how much the depth of the cut will be taken by the tool in each step. So for example, let me define to 0.2 millimeter. It means that 0.2 millimeter cutter will take 0.2 millimeter depth each step while performing this operation. And how about the finishing operation? It will take one cut at a step of 0.05 millimeter and perform a finishing operation at the end. Okay. So the linking parameters will define how much depth you want in this operation. So let's define the retract point is 25 and the feed plane is 2 millimeter above the surface, and the stock method is 0 millimeter, and the depth is let me define this depth is minus 10 millimeter. So it will go down minus 10 millimeter and create the pocket at a depth of 10 millimeter. Okay. So for that purpose, you also need a coolant to cool down your tool and the workpiece, and it will also away the cutting chips from the pocket or the cutting tool. Okay. So this is how it creates a tool path, and you see that how it works. Let me show you from the top side. So it will take the zigzag method to perform the cutting operation, and after doing all this, it will create the profile operation to clean down the process. Okay. So we did the pocket milling operation, and let me show you how it will look like. Let me hide the face milling operation. You just need to click on the face, and this toggle display option will help you to unhide the tool path. So we have selected the face milling operation and hide the tool path. So let's check how it will get the material or how the pocket operation will work. So this is how the pocket milling operation is being performed, and it will clean the operation. This is what we call the profiling. Okay. So this is the line profile milling operation. It will take, you will see that here the Z option is shown that it will take 0.2 millimeter cut each step. So is 0.7 and then 8 and 9. Okay. So 0.99, it's all about the 1 millimeter testing. Okay. So it's 1.2. So it's taking 0.2 millimeter cut in each step. Okay. So you see, it's not giving the full amount of values because it has to remove the material or the finishing amount, and it has some tolerance values added in by default in the control system. Okay, so it will down and do down at me. Now get this fast. So it will go to minus 10 millimeter. And you can calculate the time after creating all these toolpaths. You will get the machining time afterward. Okay, so you don't need to worry to calculate the time. Mastercam will automatically calculate your machining time according to the operations and the parameters you have selected. Okay, so it has completed it and it goes back towards to Z25, which is an retract point, or we can say that the same. So we got the pocket milling operation done. First we have did the face milling operation, then the pocket milling operation. Let's get towards the drilling operation.